some planes fall out of the sky?
Actually, you better ask your mother that one.
When children first ask questions, it's just a strategy for keeping up a conversation.
Where does the sun go at night?
But for Finley, age 6, questions have taken on a new significance.
Why do people stop singing when you turn the radio off?
Finley's got it into his head that things happen for a reason. He's striving to understand how things work, so that the world will become a more secure and predictable place.
Why do people not fall off the edge of the earth? Did Father Christmas invent God, or did God invent Father Christmas?
But while Finley may be fascinated with why things happen, he can't yet reason like an adult.
Why are there clouds?
Well, we're out at sea.
At Finley's age, children reason by association. They plump for the first thing that comes into their heads. As that tends to be what they see, their answers are based on the appearance of things rather than any underlying logic. So why is the sky blue?
Because blue goes with yellow. Because the sun is blue. So you can see the white cloud. As well, because then it's nicer. If it was always dark, it wouldn't be very nice.
What are clouds made of?
Foam. They're like rocks. Wool and feathers and fluff. So they can, and someone has to hold them up, and no one can. They just put them up in the sky, and the sky holds them up.
Why don't people fall off the bottom of the earth?
They have to hold on tight. Really tight. In the night time, then the Australians would fall down, and then in the night time we'd fall down. No. So it's something about God that keeps us up and makes it look like if we were up. Like if we were up like this. Down if you... Because they're actually upside down, but they think they're up.
The emergence of logical thinking is revealed in a simple experiment. Ewan is shown 2 tall glasses filled with equal amounts of juice. He is asked to check that the amounts are the same in each glass. Then the juice is poured from one tall, thin glass into a short, fat glass.
And more.
Then Ewan is asked a question.
What?
Does one glass have more and the other glass have less? Or do they both have the same amount?
One have less.
Which one has less? And which has more? The experiment is repeated several times. Each time the children are asked to check that the amounts in the 2 tall, thin glasses are the same before one is poured into the short, fat glass.
I'm going to drink that. Are we going to drink it? That one has less and this one has... what's it called? More.
The under 5s are unanimous.
That one has more than that one. That one has more and that one has less. That one's got more. That one has more and that one hasn't. That's got more and that's got less.
These children aren't ready yet to cope with an abstract concept like quantity. They still think in the here and now, and they can only think about one dimension of a situation at a time. In this case, height. So since the levels in the short, fat glass are lower, it must contain less juice. But between the ages of 5 and 7, the answers change.
The same, probably. Or because it's fatter, it looks smaller.
They're exactly the same.
They're the same.
And how does Rory know they're the same?
Because when you pour the water in from that glass, you're just pouring in exactly the same amount, and those two glasses were both exactly the same.
The older children can think about quantity in the abstract. They can remember the tall, thin glass from a few moments ago. They can think about the height and the width of both glasses and draw the logical conclusion.
They're exactly the same. It's finished.